Good morning, everybody. I'm Subhashini Mutaliar. Today I'm going to take a second part of hydrogen. In this, we are going to study about the importance of water. What is the use of the water? Okay, let's start with that. A major part of all living organism is made up of water. As you know that 3/4 part of the earth is made up of water, and 1/4 part of water is land. Human body has about 65%, and some plants have much as 95% of water. It is a crucial compound for the survival of all living forms, life forms or living forms. It is a solvent of a great importance, so it's called as a universal solvent. Different uses of water, as you can see here, in the domestic purpose, industrial purpose, in for gardening, and for the agriculture based, as well as domestic. We can see here for the bathing, toilets, washing machines, right, and washing clothes. Okay, so now we are going to study about the physical properties of water. See, different uses of water, that is industries, agriculture, domestic purpose, right. Now, physical properties of water. It is a colorless and tasteless liquid. The unusual properties of water in the condensed phase are due to the presence of extensive hydrogen bond between the water molecules. So, the bond between the hydrogen and oxygen is very strong. Water has a higher specific heat, thermal conductivity, surface tension, dipole moment, and dielectric. Uh, Water has a higher specific heat, thermal conductivity, surface tension, dipole moment, and dielectric constant when compared to the other liquid. So, thermal conductivity, as it has a good conductor of electricity. Thermal means heat, thermal conductivity. The surface tension is also high over here in the water, so if you will drop a pin, so it will slightly float on the water, so that is the surface tension. We have studied in chapter number 5 about surface tension, right. Dipole moment, the polar dipole moment, right. Dielectric constant when compared to the other liquid. So it is an excellent solvent for transportation of iron and molecules required for the plant and the animal metabolism. It's a universal constant, it's a solvent. So due to the hydrogen bonding with the polar molecules, even a covalent compounds like alcohol or carbohydrate dissolve in the water. Why? Because of polar molecules, right. Hydrogen bonding with the polar molecules. Now about the structure of water. In the gas phase, water is bent molecule with a bond angle of 104.5 degree and OH bond length of 95.7 picometer. It is highly polar molecules. In the liquid phase, water molecules are associated together by a hydrogen bond. The density of water is more than that of ice. Hydrogen bonding in the water. So the hydrogen bonding of water, hydrogen bonding is what? See here. Hydrogen bonding are chemical bonds that forms between the molecule containing a hydrogen atom bonded with a strongly electronegative atom. So because the electronegative atom pulls the electron from the hydrogen atom, the atom forms a very polar molecules. So mean one end is a negative charge and the other end is a positive charge. So hydrogen bond forms between these molecules because the electronegative ends of a molecule are attracted to the positive end and of the other molecules. So the hydrogen bond in the water molecules is how you can see over here, that the bond generally you can see here hydrogen, oxygen, and hydrogen, H2O, right. So hydrogen bonding in the water. So we are discussing this one. Okay. Now, the structure of ice. Ice has there is a crystal structure of a ice also there. So ice has a highly ordered three-dimensional hydrogen bond structure. The examination of ice crystals with the X-rays shows that each oxygen atom is surrounded tetrahedrally by four other oxygen atoms at a distance of 276 picometer. Hydrogen bond gives ice a rather open type of structure with a wide hole. These holes can hold some other molecules of a appropriate size interstitially. So the structure of ice, even over here you can see the different form of a structure which shows hydrogen bonding, and it gives open type structure with a wide hole, and these holes can hold some other molecules of a appropriate size over here. Yes, then Redox reactions involving water. Water can be easily reduced to dihydrogen by highly electropositive metals. So water, when reacts with the metal, gives metal hydroxide plus hydrogen. So the source we are getting of dihydrogen is metal plus water. And next one is water is oxidized to oxygen during a photosynthesis, that you know or you very well that carbon dioxide plus water gives glucose plus water plus oxygen. So with fluorine it also oxidized to oxygen. Fluorine plus water gives fluorine, fluoride, hydrogen ion and oxygen. So next one is what? Hydrolysis reactions. Due to high dielectric constant, it has a very strong hydrating tendency. It dissolves many ionic compounds, however certain covalent and some ionic compounds are hydrolyzed in the water, that is a P4O10, this chemical equation, so you have to remember it. Plus water gives H3PO4, phosphoric acids is silicon chloride, silicon tetrachloride, plus water gives silicon dioxide plus hydrochloric acid. Nitride ion with the water gives ammonia and hydroxide ion. This is the hydrolysis reactions, which all the salt and the metal ion requires the hydrolysis, that is water. Now about the temporary hardness of water. What was that temporary hardness of water? The temporary hardness is due to the presence of magnesium, that is some element present in the water, that is a magnesium calcium क्षार बोलते हैं ना हम, right? Temporary hardness, and how it can be removed? It can be removed by the boiling, right? So by boiling, what happened during boiling? The soluble of a magnesium hydrocarbonate is converted into the insoluble magnesium hydroxide. Calcium bicarbonate converted into the insoluble calcium carbonate. So this helps what is a remove of carbon dioxide and water, right? So this is temporary hardness. Now Clark's method. So in this method, calculated amount of lime is added to hard water. It precipitates out the calcium carbonate and magnesium hydroxide, which can be filtered off. So in the Clark's method, the lime is added over there. So lime is what? CaOH twice. Not lime, it's not lime water, it is a lime, that is CaOH twice. Okay, so calcium carbonate plus water is there, and so we can filter it out, we get the pure form of water. Now about the permanent hardness. So it is due to the presence of soluble salt of magnesium and calcium in the form of chloride and sulfate in the water. So the permanent hardness is not removed by boiling. It can be removed by what? That is treatment with the washing soda, that is sodium carbonate. Washing soda reacts with the soluble calcium and the magnesium chloride and sulfate in a hard water to form insoluble carbonates. So magnesium chloride, when reacts with the sodium carbonate, gives metal carbonate plus NaCl, right? So the arrow mark down, it shows the precipitation. So it can be removed through the filtration. Okay, the next method is what? Calgon's method. Now what is Calgon's method? So in this Calgon's method, sodium hexametaphosphate, that is Na6P6O18, is used, that is called Calgon. When added to the hard water, then what has happened over here? So Na6P6O18 on the reaction with the metal, it gives a salt and Na plus ion is separated. So the complex anion keeps the magnesium and calcium ion in the solution over here. So this is the catalysis method. Now ion exchange method. So in this ion exchange method, the method is also called the zeolite. So what is zeolite? That hydrated sodium aluminum silicate, that is a NaAlSiO4 with the water, is called as a zeolite, and it can be written as a NaZ, right? So NaZ plus metal gives metal zeolite plus Na is removed from here. So this is the ion exchange method. Now the next method is what? Synthetic resin method. So this method is more efficient than the zeolite process. Cation exchange resin contains large organic molecule with a SO3H, that is what sulfonic acid group, are water insoluble. Ion exchange resin is changed to Rna by treating it with the NaCl. The resin exchange Na ion with the Ca plus 2 and Mg plus 2 ion present in hard water to make the water soft. So here R is a resin ion which makes the hard water soft. Okay. Now about the hydrogen peroxide. So H2O2, you know very well what is the H2O2, hydrogen peroxide. So H2O2 is an important chemical used in the pollution control treatment of domestic as well as industrial effluent preparation. How it is prepared? H2O2, it can be prepared by the following methods, that is acidifying barium peroxide, that is BaO2, and 8 times H2O plus H2SO4 in presence gives barium sulfate plus H2O2 plus water. The second method is what? Peroxide is sulfate obtained by the electrolytic oxidation of acidified sulfate solution at a high current density on hydrolysis yields hydrogen peroxide. So the equation is given over here. So there are some physical properties also of H2O2, that is melting point is 272.4 Kelvin, boiling point is minus 423 Kelvin, and vapor pressure is 298 Kelvin. And it is miscible with the water in all the proportion and forms a hydrate H2O2 dot H2O. So 30% of H2O2 is marked with the 100 volume. So it means what? 100 volume of hydrogen peroxide. It means that 1 ml of 30% H2O solution will give 100 volume of the oxygen at a standard temperature and the pressure. So these are the physical properties. Now storage we will do. How to keep it? Now H2O2 decomposes slowly on exposure to the light. So in the presence of a metal surface or traces of alkali, the above reaction is catalyzed over here. So it is therefore stored in a wax lined glass or a plastic vessel in the dark. It is kept away from the dust because dust can induce the explosive decomposition of the compound. So it should be kept in a proper way. Now where it is used? It is used as a hair bleach, as a mild disinfectant, as an antiseptic. It is sold in the market as a perhydrol also. It is used to manufacture chemicals like sodium perborate and percarbonate, which are used in a high quality detergent. It is used in the synthesis of a hydroquinone, tartaric acid, and certain food products and pharmaceutical companies also. It is employed in the industry as a bleaching agent for textiles, paper pulp, leather oils, fats, etc. It's also used in the environmental chemistry. So these are all the uses of the heavy water, that is H2O2, hydrogen peroxide. Now heavy water. Heavy water is what? Is different from the water and the hydrogen peroxide. This is D2O. It is extensively used as a moderator in a nuclear reactor and in an exchange reaction for the study of the reaction mechanism. It can be prepared by the exhaustive hydrolysis of a water or as a byproduct in some fertilizer industries. And the physical properties are what? That is melting point is 276 Kelvin, boiling point is 374, molecular mass is 20.0276 gram per mole. Now the last topic is what? So dihydrogen as a fuel is very important, that the dihydrogen gas is used as a fuel. So dihydrogen releases large quantity of heat on the combustion. Dihydrogen can release more energy than the petrol. Hydrogen economy, the basic principle of the hydrogen economy is a transportation and storage of energy in the form of liquid or a gaseous dihydrogen, and energy is transmitted in the form of dihydrogen and not as a electric power, right? It is also used in a fuel cell for the generation of electric power. Okay, so that's all for the chapter. We have finished the chapter. Okay, read the question, answer, and try to complete the lecture exercise in the classroom. Okay, bye bye.